Now you've learned about designing classes using class diagrams. So now let's see how we can write a class with real C++ code. We're going to use the donation tracker example on the worksheet, and we're going to break down the syntax for this donation tracker class. So the first thing that you see is this keyword, this class keyword, which we use to specify in C++ the name of the class. So we have the keyword class, and then we follow it by the name of the class that we're implementing. So in this case, we have the donation tracker class. And then if you notice within the class, it seems to be divided into two indented chunks, either public or private. And these keywords are called access specifiers. And what they do is modify where members of the class can be used or accessed. So in the public section of the class, we list the members that can be accessed outside of the class. And usually, most or all of the member functions will be in the public section of the class because we want those functions to be able to be used externally. So outside of the class, we want to essentially say people can use these functions to interact with and use objects of the class. So this is like the public interface that people can use. In the private section of the class, we list the members that we want to hide from the outside world. So this keyword essentially says that everything under this indented block in the private section can't be accessed from outside of the class. So these things can only be accessed from within the class. So in this case, we have the donations underscore variable, which is a private vector, right? So that means that this vector can only be accessed, this donations variable can only be accessed from within the donation tracker class. So we can access it from the donate function or the average donation function, but we can't access it anywhere outside. So externally, we have no permission to access the donations vector. And in general, it's good practice to keep the member variables private so that we don't risk allowing people to access the underlying state. If we want to allow people to make changes to the state, we generally can use public member functions called getters and setters that allow us to access or mutate an object state. And that way, we can explicitly define in our public interface that people can make a change to the state if we want them to. In this case, since we've created a class to represent a donation tracker, we just want to store all the donations and record them in this tracker. We don't necessarily want to allow people to make unwanted changes to our list of donations that we're tracking. So we keep the donations vector private to prevent anyone from, say, deleting a donation that we want to keep track of. So take a moment to look at this block of code that we have on the right and try to guess if this would compile based on what you know now about the public and private access specifiers. If you need more time, you can pause the video now. So notice that this code is written within the main function, which is outside of the class. So that means that from here, we can only access the public members of the class. So the very first line here, donation tracker, this calls the default constructor. This is the syntax to call the default constructor, which is the very first member function in the public section of the donation tracker class. So that's fine. The second line of code uses dot notation, and we're making a call to the donate function. And the donate function is also in the public section of the donation tracker class. So this compiles just fine. We can access public members from within the main function. Now take another moment to look at this block of code and guess if it would compile. You can pause the video now if you need more time. In this code, we're trying to access the donations underscore vector, which is a private member variable. And since it's private, we can't access it from the main function, right? We'd see some error indicating that the variable that we tried to access is private, like this one. So the donations underscore member variable is private within the main function, so we can't access it here. So we would get some compiler error. So in C++, we generally split up our classes into two different files. Header files, or files that end in .h, are where we put the class declaration. And implementation files, or files that end in .cc, are where we implement the member functions that we declared in the class in the header file. And you might wonder, why don't we just consolidate everything into one file? And one benefit of keeping the declaration separate from its implementation is that people only need to look at the header file to understand what the class does and how they can use it. We don't need to necessarily see the potentially super complicated logic in the implementation file. All we need to know is the public interface, and from that, we have all we need to use the class and instantiate and use objects. So think of as an example when you use the vector or the map class. We know that we have certain functions that we can use, like pushback or insert, but we don't necessarily know what's happening under the hood. We just need to know the public interface of functions that we can use to do what we need to do with our vectors and our maps. We don't need to know how they're represented under the hood. So for member functions that we declare in the header, we'll implement them in the .cc implementation file. And when we implement that function, we need to specify the name of the class that that function belongs to. So if we have the donation tracker class in the header file here, and we declare this average donation function, then in the .cc file, we'll put the average donations implementation inside. So when we implement it, we have to specify the name of the class. And the name of the class that this average donation function is in is the donation tracker class. So we have the donation tracker and then 2 colons followed by the name of the function that we're implementing. And what this does, essentially, it tells the compiler that this average donation function belongs to the donation tracker class. And this is needed because you might have multiple classes that have member functions with the same name, right? So if you have 2 different classes and they both define an average donation function, having donation tracker : in front of it resolves any ambiguity on which member function you're implementing. So you know that this implementation file, this implementation of average donation, is specifically for the donation tracker class and not any other class. So the general syntax for this is that in this .cc file, we'll have the class name followed by 2 colons and then the name of the function. Finally, a lot of the member functions are defined in the .cc implementation file. But sometimes we'll have functions defined within the header file in the class definition, in the class declaration. And when functions are very short and very simple, you might choose to leave it within the header. What these functions are called are inline functions. So in the donation tracker class here in the header file, we had an example of an inline function, the donate function. If you notice, we didn't follow the function prototype with just a semicolon, right? Void donate and then the parameter double donation. We could have just put a semicolon right after and then defined it in the implementation file, in the .cc file. But instead of following it with a semicolon, we have these braces and then we have this one line of code, which is the body of the donate function. So this is called an inline function, and the benefit of this is that it can help with readability because it's a very short and simple function, but it also helps with efficiency because smaller functions can be, like, there's some overhead with making a function call, and with these very short functions, we can avoid that overhead because they're super simple, and making the function call sometimes could be more expensive efficiency-wise than actually performing the operation within that function. So if a function is very short, you might want to define it inline. Stylistically, based on the Google C++ style guide, we suggest defining a function inline only if it's less than 10 lines of code and doesn't have more complex pieces of logic, like, say, if it has any for loops in it. So if it doesn't have that and it's short, then you can define that function inline within the class. So generally, this might be like your getter and setter functions because usually those are only 1 line of code.